Scientific measurement is nice when it's standardized because it's easy for us to communicate with other scientists what we're measuring, what our experiments are about. So the scientific community, especially in France, came up with a way of determining, or not really determining, but using a common type of measurement, right? It's what we call the metric system. Okay, it's also called Système International. That's what the French call it. We call it metric, and it's a way of standardizing and putting to base 10 all of our different measurements. Okay. For example, let's look at mass. Okay, what's the unit for weighing mass? And the metric system, it's easy. It's gram. Okay, abbreviated with a lowercase g. And what is it in the English system? Okay. There's the ounce. There is the pound. There's the stone. Okay, it's about 20 pounds. Right? So 3 different mass measurements that are there with the ounce, pound, and stone. Okay? When we go to volume in the metric, again, it's easy. It's a liter. The liter is represented as an L. Okay? And in the English measurements for volume, we have pint, we have quart, we have gallon, we have teaspoon, we have cup, we have tablespoon, we have gallon. We have a lot of different ways of measuring volume in the English system. Again, the metric is nice because it just puts it down to one specific measurement. Distance, it's the meter, represented by a lowercase m. English measurements, you're looking at miles, or you're looking at inches, you're looking at yards, feet, right? All of those things are English measurements. Time is one that's actually universally shared by both of these things. Both of them use the second. Okay? And the second itself, all right, obviously it's SEC. Okay, sec. Okay, same over here, sec. Okay, the second, the minute, the hour, all of those are both interchangeably used between metric and English. As far as energy goes, generally we use the joule here. In the English measurements, there's things like erg, right, which is a energy measurement. But for a lot of times, you're seeing a lot of the English system going over, or horsepower is another one. We generally stick to joule. And joule, the uppercase J at this point. Okay. You'll also see the calorie, which is also used between both systems. The calorie is lowercase c-a-l. All right. Bigger calories, also known as kilocalories, are the food equivalent calories that you see on labels. Now, you have to know what the prefixes and suffixes are and when we're using metric measurements. So these things are important. All right? I am going to use gram here as sort of a base scale. All right? So here I'm going to say 1 gram. And what this is 10 to the 0 grams. Okay? And it's just regular gram. We're not going to put a suffix or anything associated with it. When I get to 10 to the 3rd grams, okay, I now have the kilogram. Okay? It's abbreviated with K. So at this point, this would be kg, kilogram. All right? When I get to 1,000 kilograms, it's 10 to the 6th, I am now going to get to a megagram. Okay? In the megagram, it's a capital M and a lowercase g. Okay? Looks like magnesium, but don't think magnesium, it's a megagram. If I go to 10 to the 9th, it's a gigagram. So GG, okay, the gigagram. It's a lot of mass at that point. And above that is teragram. TEG, 10 to the 12th. For all you computer nerds out there, this is the size of hard drives. Okay? It used to be kilobyte, then megabytes was the standard for a very long time. So we got up to gigabytes, where a lot of things are right now. If you get a really big hard drive, it's a terabyte. So it's 1,000 gigabytes, or 1,000 megabytes, or 1,000 kilobytes, or 1,000 bytes. Okay? When we start going down the other part of the scale, when we get smaller, 10 to the minus 3, that's a milligram. Okay, so it's a milligram there. I go to 10 to the minus 6, and that's micro. Now notice both of these start with M. Milligram is the lowercase m at this point. Microgram looks like a U, okay, or unfinished M. That's microgram at that point, okay? When I get to something even smaller than the microgram, that's 10 to the 9th, this is the nanogram. Oop, not mammogram, that's a medical test. Nanogram. A nanogram is NG, okay? Nanogram means small, good. All right, and below that we go to picogram, or is it femtogram? Yep, it's picogram. PG, that's 10 to the minus 12. And below that there's even femtogram, which is even smaller. Right? These are all the ones 10 to the 3 powers that we want you to know as far as science goes. There's a couple more that get stuck in here. Right in this region, you'll run into centi, which is 10 to the minus 2, and you also run into deca, which is 10 to the minus 1. Or, excuse me, not deca, deci. Decigram. Okay, it's an I. Decagram implies that it's larger than that, larger than 0. Now you look at these numbers, these values, these exponents, and you're like, okay, that's science terms, that's awfully nerdy. Wasn't needed as far as actual numbers go. Right? So if I have 1 gram here, so I'll put 1 gram here, that's 1 gram, 1.0. Kilogram is 1,000 grams. Mega, that's 1,000,000 grams. Giga, that's 1,000,000,000 grams. All right, and tera is 1,000,000,000,000 grams. Okay, give you an idea. Our government, is getting close to $20 tera in debt. That's a lot of zeros. We go the other way. For milligram, that's not number of grams. Okay, for microgram, we're down to there. To nanogram, right, we're getting even smaller. And we go to picogram. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? This is where the number is. So that means I'm going to have 11 zeros before the first number in pico. Okay? And this one I'm going to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And that's where the number is. Okay? That means how small the magnitude of my value is. What this also means, if you look at it this way, is 1 over 10 to the 9. And this is 1 over 10 to the 6. 1 over 10 to the 3. So when you have a fraction like that, 1 over 1,000, it's 1,000. Micro is 1,000th of something. It's a very small value. Okay? You need to know all of these to be a good scientist. All right? So when you were doing these types of conversions. Okay. We're going to talk about temperature and how we use things for temperature. For science, for the metric, we use Celsius primarily. and we also use Kelvin. And these two things are kind of interchangeable. There's a big difference between the two, though. All right? Those are the ones we're going to use in science now. And I'll explain the difference here in a second. But let's talk about Fahrenheit. All right? At 32 degrees Fahrenheit, that's the freezing point of water. So at 32 degrees F, our Celsius term becomes 0 degrees centigrade, okay, or Celsius, 0 degrees C. And at this point, this is 273.15 kelvins, right, or degrees K. I call it kelvins. I was always taught that Kelvin, you don't say degrees Kelvin, but that's just me, okay? When I get up to 100 degrees Fahrenheit, all right, my degrees as far as Celsius goes, I move to something that isn't really that clear. And I get a temperature of 37.78 degrees C. Okay? When I get to Kelvin, the easy way to do Kelvin is that I take this value and now I'm going to add absolute zero. So add 273.15, and that's going to give you what the degrees Kelvin is going to be. Okay? Or the kelvins. And that comes out to 310.93. Now I'm using a calculator to help me figure this out. Okay? There's some conversion tools you may find online. The base conversion for using these things, all right, is to find degrees Fahrenheit. What I'm going to do is I'm going to take the degrees Celsius, multiply it by 9/5, and then add 32. Okay? Another way of looking at this is if I take degrees Fahrenheit, okay, subtract 32, and then multiply it by 5/9, I will get degrees C. Okay? So I just want to make sure that that's correct. Let's do a conversion with that. Okay? So suppose I have 75 degrees Fahrenheit. All right? I want to find the degrees in Celsius. So that's going to be equal to degrees C times 9/5 plus 32. So if I'm going to solve for degrees C, I subtract 32 from both sides. So subtract 32. That term falls out. And now what we're going to have is 43. 43 is now equal to, and don't forget your units, knock her away. 43 degrees Fahrenheit is going to be equal to degrees C times 9/5. Okay, so now if I multiply both of these by 5/9, I should get my overall term, right? So I multiply this by 5/9. The 5 cancels, the 9 cancels. And what I'm going to be left with is a balmy temperature of 23.89 Celsius. Or in this case, I'll round up to 24 degrees C. All right, so 24 degrees is equal to the degrees C at this point. All right, and that's how we do this type of conversion. Yeah. If we want to find Kelvin, always just add 273.15 to it. Now, I did say that there is something that you have to kind of be careful of in Celsius and Fahrenheit. For example, suppose my degrees Celsius, suppose I have minus 17 degrees Celsius. Okay? My kelvins at this point, if I take 273.15 and subtract 17, my kelvins are 256.15. Now I want to point this out. All right. The big difference here is that this is a positive term and that's a negative term. When we talk about thermodynamics, you never want to go through a sign change. It's unnecessary. It'll throw all your calculations off. So in science, whenever we're dealing with thermodynamics, you've got to stay with the K scale, the Kelvin scale. And in doing so, that makes sure that whenever you do have a sign change due to energy being released or energy being absorbed, you're not being thrown off by a negative sign introduced by an arbitrary scale. All right? So Celsius, you want to have, you can use that for a lot of calculations. Changes in Celsius is generally not a big deal. But when you're looking at thermodynamic values, it's always safe to stay on the Kelvin side of the scale. All right, so now it's just for practice. Let's do this. Let's find out degrees Fahrenheit if I'm at minus 17 degrees Celsius. All right, so remember our equation, all right? Degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32 degrees. Okay, that's our conversion. So now I've got minus 17 times 9 divided by 5 plus 32. Okay, so now we do our math. Now we want to get our calculator out. Okay, 17 negative times 9 divided by 5 is going to be minus 30.6 plus 32. And I get a value of 1.4 degrees Fahrenheit. Okay, that's a cold day, 1.4 Fahrenheit. I should note that right now I'm playing fast and loose with something called significant figures. And I'm going to introduce significant figures here after I introduce the complex terms that we run into in chemistry.